let's take a look at today's lesson. We really are covering two topics today. We're going to solve rational equations and we're going to work with inequalities. Actually, not just rational inequalities, with three different kinds of inequalities. So that's our goal for today. So we're going to start out with solving rational equations. Okay, so on that first one, what we're looking for, we've got fractions. We love fractions, right? Fractions are our friend. Fractions are our friend. And so what we're hoping for actually on that is that if they're nice to us, then the factors of this are going to be these two factors. If they're not that nice to us, then they're not going to be, and it's going to be a bit more complex. But so that's what we need to do first, is determine what is the common factor. We need to find that. So if we factor this, we actually get x minus 2, x minus 4. So they are being nice to us this time. That is the common denominator. So what I'm going to do, just for, I guess, ease, I do the same thing every time. I'm going to find a common denominator as I'm moving everything to one side. We really need it to equal 0. Okay, I'm going to just keep talking about equaling 0. We can't have it equal 1 or something else. It has to equal 0. So I'm going to move all that to the left. So we have 4 over, and we'll just leave it factored, x minus 2, x minus 4. I'm going to subtract that others over, so minus 3x times. So this has an x minus 2, so I need to multiply by x minus 4 over x minus 4. So x minus 4 over x minus 4. My next fraction, I have a 2 here. I have an x minus 4 in the denominator. So that means I need to multiply by x minus 2 over x minus 2. So x minus 2 over x minus 2 equals 0. So that's my goal. We want it to equal 0. We good? We're just finding common denominators. We're pretty good at that now. So I'm going to combine all those together into one fraction. One option would be to go ahead and distribute this negative 3x as we go. That's one thing to do. That's what I'll do. I'm just going to start. So my numerator is 4. So I'm going to do a negative 3x times x is negative 3x squared. Negative 3x times a negative 4 is a positive 12x. Continuing on, I have a negative 2 times x is negative 2x. And negative 2 times negative 2 is a positive 4. And that's all over our common denominator equals 0. Just always trying to help. One of the most common mistakes that I see is forgetting to distribute this negative to the terms. So let's just be careful when we're doing that. Okay. So when I get it into one fraction, what I typically will do is I'm going to stop just for a second and I'm going to notice what x cannot be. And I actually write it down. I don't want to get to the end of the problem and forget. So I just go out to the side so I know x is not allowed to be 2 or 4. And I just kind of circle it. Okay, so hey, that just kind of gives me the clue. It can't be 2 or 4 when I get to my answer. Once I do that, I actually discard the denominator. And that always troubles students. I just want to talk to you. It's okay. Why is that okay? Because I'm equal to 0. Because I'm equal to 0. So I want the numerator to be 0. I don't care what the denominator is as long as it's not 0. 0 over 2 is the same thing as 0 over negative 20, which is the same thing as 0 over 5,000, right? They're all the same. It doesn't matter what the denominator is, so I don't really need it. I'm just going to discard it. I'm going to just deal with the numerator. Okay, so we'll just deal with the numerator. Now, if this were equal to 1, I would not be able to do that, right? It would matter what the denominator was. If the numerator was 4, the denominator would have to be 4. The only reason I'm allowed to discard the denominator is because I'm equal to 0. See what a big deal equal to 0 is? It's got to be equal to 0. Alright, so I'm going to just deal with the numerator. So I have 4 minus 3x squared plus 12x minus 2x plus 4 equals 0. Okay, so let's combine like terms. We got a negative 3x squared. Let's see, a plus 10x and a plus 8. Now I'm going to need to factor. I really do not like factoring with the leading coefficient negative. I just don't. I mean, some of you are probably great at that. I just really don't like it. So since I have an equation, I have a little bit more freedom. I'm going to multiply the whole thing by -1 so I don't have to deal with factoring with this leading coefficient negative. So I'll multiply through by -1 and I get 3x squared minus 10x minus 8 equals 0. So now let's factor. So my factors are 3x plus 2, and my other factor is x minus 4. So I set each factor equal to 0. I guess I'll physically do that. I'll set it equal to 0 just so we're clear what I'm doing. So x is going to be a -2/3, or x is going to be a 4. And then I think, wait a minute, I wrote down things x could not be, and 4 was one of them. That is not an actual answer. So I crossed through it. It's not an actual answer. My only answer is -2/3. Okay, so that's just a little bit of a review on how to solve rational equations. Are we okay with that? Okay. All right, so now I do the same procedure every single time. I mean, nothing varies. Everything will do the same every time. All right, so let's then talk about inequalities. We really are going to be working with 3 different kinds of inequalities. We'll work with polynomial inequalities, rational inequalities, and absolute value inequalities. This little chart right here is talking about absolute value inequalities. So let's take care of this, and then we'll go to the next slide. So if we have a less than, you probably remember less than is and, greater or is or. We try to make a deal of that. They mean different things. And this only applies to absolute value. I had some students trying to apply it to polynomials, and no, this is talking about absolute value, the and the or thing. Okay, so what does this mean? Let's look at this graphically, what it means, because it really is a huge deal. The answers are going to be vastly different depending on which one of these we have. So let's talk about the ands first. And is most restrictive. This less than is most restrictive. It means that, so when we have an absolute value, we have 2 of everything, right? 2 inequalities, 2 equations, whatever we're working with. It means that the solution is where the 2 sides meet. If they never meet, there's no solution. So if I have a graph, let's say my solution set looks like this, and it's an and, this would be no solution. They don't ever, they are never in the same place. And the answer to an and is where they cross. Okay, and these never cross, so that would be a no solution. What if I had an and whose solution graph looked like, I don't know, let's say it looked like this. What if I had an and that looked like this? Then my solution would be this part over, right? Right, where they're the same. So we see that significant difference. Now let's turn it around, and let's say, what if, I'm going to use these very same graphs. What if I had an or graph that looked like this one and went this way? Well, for or, it's really like whatever, it's everything, right? Everything, it doesn't matter. They don't have to be the same. It's basically either or. So this one's going that way, that one's going that way, so both of those would be the answer. They both would. Whereas if it were an and, we wouldn't have an answer. You see what I'm saying? So this one, you know, say that's a -2 and that's a 5. So basically, our answer would be from -2 to -infinity, or if we want to do it, -2 to -infinity to -2, and then from 5 to infinity. This, if it were an or, would be our answer. An and would be no solution. What about this little scenario right here? If this were an or, the answer would be from here over. Okay, so the big significance is, if it's less than or and, the answer is where they cross. If it's a greater or, then all of it is the answer. Everywhere it crosses, everywhere it touches the solution is the answer. Okay? All right, so that's why it's kind of important to draw this out. If we don't draw this out, we may make a mistake and have the wrong answer. Okay? So, questions about that? That just should be a refresher. Okay, so let's go to the next slide and work some inequalities. Okay, the first one is a polynomial inequality. And what we're going to do is we're going to factor it. So what? Okay. Oh, nope. So let's see. So we have a minus 6. Yeah, that's right? We good? Minus 6. Oh, there we go. Yep. Because the back sign's positive. Alright. So the back sign's positive. They have to be the same. And then we need to get a 5, so 2 and 3. Alright, so what we do is, the reason that we're factoring is because we want to know where this polynomial is 0. We want to know where it's 0. That's what's going to go on a number line. We're going to do sign analysis. And so we have our number line. We've got a 2 and a 3. When we're doing, now sign analysis is a pretty big deal in calculus. We do it often. So hopefully you're pretty good at this by now, but I'm just going to go through it and remind you. I encourage you to not write a bunch of numbers down on your number line. What I see happening when students write their test numbers on here is that sometimes they forget which is the actual answer number and which is the test number, and they get them mixed up. So I encourage you to do it in your head. I know a math teacher telling you to do something in your head is probably just like, oh my gosh, what? But in this case, I really do encourage you to do it in your head. So I'm going to just choose a number, 0, on this from this section, and I'm going to put it. It doesn't matter which equation I use, whichever is more convenient. For 0, it'd be kind of nice to use this one. I put a 0 in. I'm left with a positive number. Okay, great. That section is positive. If I'm using a 2.5, for me, it's more convenient to put it down here in the factored form. 2.5 minus 2 gives me a positive number, and 2.5 minus 3 gives me a negative number, right? Positive times negative is negative, so that section is negative. Put a 4 in, and I get positive. Now, some students have noted that a lot of times the pattern just changes, like it alternates, plus minus, plus minus. With a polynomial, you can be sure that that's true, but not with other kinds of, like a rational, that's not necessarily true. You should really just check all the sections. Just make sure. Just get into a habit of checking all the sections and saying, oh, the first one's positive, so it goes positive minus positive. Well, probably 70% of the time you would be right. Okay, well, it would be better to just check. So now we're looking at, we want this quantity to be smaller than 0. So this quantity is smaller than 0 right here in the middle, right where it's negative. Now, since this inequality isn't an or equal to, I don't have a chance of having a bracket, period. They're going to be parentheses. That's really the easy one. It's just parentheses. You don't have to worry about it. So my answer, if we're doing interval notation, my answer would be 2 to 3. No brackets because this is just less than. Now, on the daily work, it asks you to graph the solution set. So I'm going to go ahead and do that. Graph the solution set. It just says this is called the solution set. That's what this is. And my graph would simply look like that. That's all it's asking you to do. If you want to do this graph on your sign analysis chart, you could do that too. That's fine. You don't need to do a separate graph, but you could. Alright, so that's polynomials. For rational inequalities, well, first of all, it's greater than or equal to 1. That's not okay. Okay, it has to be a 0. We've got to move the 1 over. It has to be a 0. So I'm going to subtract the 1 to the other side and get a common denominator at the same time. So I have 1 plus x over 1 minus x, and then I'm going to subtract, move the 1 over, so 1 minus x over 1 minus x, greater than or equal to 0. Okay, is that okay? I just did two things at once. I moved the 1 to the left, and I also changed the 1 to have a common denominator with the other fraction. So now let's combine those fractions together. I have 1 plus x, then I have a minus 1 plus x. Okay, combining like terms, the 1's go away, and I have 2x over 1 minus x is greater than or equal to 0. Now to get the numbers for my sign analysis here, and I guess I'm just going to write it out this time. There was a little confusion earlier today. I'm going to find the zeros of that fraction, which means I set the numerator equal to 0, and I'm going to find the undefineds, which means I set the denominator equal to 0. So what I'm going to do is whatever is here, I would say 2x equals 0, divide by 2, so x is 0. Okay, 0 is going on the number line. I would say 1 minus x equals 0, so x is 1. So I have 0 and 1 on my number line. That's how I get them. Now, just as a visual aid, some students like to so this has the or equal to sign, so we can have a possibility for some brackets. We can never bracket in the denominator zeros, right? That's where we're undefined. So what some students like to do is like put a little hollow circle there just to indicate, so they, you get really excited and get wrapped up in the problem, and then you forget that, oh, that can't be, I can't have a bracket there. So that's what some students like to do. It's whatever will help you. So now we do our sign analysis. A little bit more complex. We've got a numerator and denominator to deal with. So I'm going to think about a negative 1. Negative 1 would make the numerator negative. A negative 1 down here would make the denominator positive. Negative divided by positive is a negative. Now 0.5. 0.5 would make the numerator positive. 0.5 would make the denominator positive. And then say 2. Positive over negative, so negative. So this happens to alternate. They don't always. I want to know where we're bigger than or equal to 0, which happens to be the center part. So I get to include, because I'm allowed to equal 0, I get to include the 0, but I don't get to include the 1. And that's what my solution would look like. Okay, if they asked us to graph our solution set, we would include that and not include that. Okay? All good so far? The last one is absolute value inequality. This is where we deal with the and or thing. So let's get rid of the absolute value bars. The way we do that is we translate it. So this is going to be negative 7 less than or equal to negative 2x plus 5 less than or equal to 7. Now some students like to leave it together and solve it as one piece. You certainly can do that. I think it's probably a little less confusing to write the two inequalities that are there. We're going to use the middle part twice. It's going to go with this side and with this side. So I'm just going to write them separately. So negative 7 less than or equal to negative 2x plus 5 and negative 2x plus 5 less than or equal to 7. Just going to do two separate ones just to avoid any confusion. Now remember the whole thing, when you divide by negative, you got to flip the sign. Remember that whole thing? So instead of doing that, I'm just going to avoid that by moving the 2x over. I'm just going to add it to the other side. So I'm going to put the 2x over here. I'm going to add the 7 over here. What is that? 12. So x is less than or equal to 6. I'm actually going to do the same thing with this one. I'm going to avoid dividing by the negative. I'm going to move the 2x to this side. And then I'm going to subtract the 7, so that's a negative 2. So x is less than or equal to negative 1. Now we need to know if they cross or where they cross. We need to know what the actual answer is, right? So let's check it out. Let's do our number line. So x is supposed to be smaller than or equal to 6, so it goes that way. And x is supposed to be bigger than or equal to negative 1, so it goes that way. So this is a classic AND where the answer is the middle part. So my answer is going to be from negative 1 to 6. And it gets to equal because I have an equal there. And we don't have any undefineds. So I could write it in interval notation if they asked me to. If they didn't ask me, I could do either way. I could write -1 less than or equal to x less than or equal to 6. That's another option for me. And then if we're asked to graph the solution set, basically we would just graph this part. And that would be it. Okay, how are we with this lesson? We okay? Okay.